Hey there, I wanted to help you go over some of this normal distribution stuff. Hopefully helps you with this Unit 2 material. Mainly be from like sections 2.4, 2.5, and 2.6. This first part here with the normal distribution here is going to come from 2.5. So we need to label the mean, standard deviations here, and they give us these values here. You guys have been doing pretty good with this stuff though, so I'm not super worried about that. So 1.84 and plus 0.07. And then minus 0.07. And titling this and putting the key. Also things I typically ask you guys to do. Let's talk about lap times. These are in minutes, so I have the units there. So what percentage of lap times are less than 1.7? So I'll notice that 1.7 is on a standard deviation. So that means we're going to be using the empirical rule here. And that's on the second standard deviation. We know that between the second two standard deviations is 95%. And so we're going to be on the outside of that. So we're looking at 5%. One way to think about this would be 100 minus 95. And since we only want half of the little wing there, we just want to divide that by 2. So, which of course is 5 divided by 2, which is 2.5. So that'd be 2.5% of the times are less than 1.7 minutes. Get rid of this stuff. What percentage of times are greater than 1.7 minutes? So that's here. So we're looking at all this stuff. A couple different ways we could look at this. We could think about, first thing I'm seeing is that I have the one standard deviation total, and then I could add on this wing, or I could take the whole thing and then cut away this portion. It doesn't really matter how you do that. I'm usually more of a fan of the adding ones. It's that idea again that between one standard deviation we have the 68%, and then we're going to take all this out here. So what's the difference between 68 and 100, and then divide that by 2. So that idea being, I'll take the 100 minus 68, because we're going back to one standard deviation, we're going to divide by 2. So both of these things here, 100 minus 68 would be that. And I also want to cut that in half and get one of those. So that'd be 32 divided by 2, which is 16. And then plus the 68. So 16 plus 68, which is 84. So 84% of the lap times are faster than 1.7, are greater than 1.7, it's not faster. Percentage are between 1.7 and 1.9. 1.7, 1.91. Again, those are both standard deviations. So I want what's between here and here. Again, lots of different ways to do this, but what I'm seeing here is I have the 68% that's between the one set of standard deviations, and I want to add on this little wing here, which is the difference between 95 and 68, but divided that by 2. So that's how I'm going to approach this. I'm going to find this first, which is 95 minus 68 divided by 2, which is 27 divided by 2, which is 13.5. And then we have the total area here of the between the one standard deviations, which is the 68. So 13.5 plus 68, which which is 81.5%. So 81.5% of the lap times are between 1.7 and 1.91. Last one of these. What lap time would be in the slowest 2.5% of all lap time? So a couple things here about this. So it's saying that, slowest 2.5%. So slow lap times are long lap time, big lap times. And so I would expect it to, to be up in this space. That we want a longer number, not a shorter number. Then it says slowest of all, so that means it's going to be, in this case also, from whatever number we're talking about, and then above it. So we want to figure out which of these sections. Is it this section that's 2.5%? Is it this section that's 2.5%? Is it this section that's 2.5%? So so I kind of want to think about like what's inside versus what's outside. So between one standard deviations is 68, and so that means on the outside is 32%, and half of that would be 16. So this line here would be the 16% slowest times, so it's not that one. Between two standard deviations is 95%, so on the outside would be 5%, and then we cut that in half and we get 2.5%. So there's our 2.5 number we're looking for. And so it's 2 standard deviations away from the mean, would give us that value. So the lap time that would be in the slowest 2.5% of all lap times would be 1.98 minutes. So here's one is draw a picture, shade, calculate z-score, and answer questions. So I think we're going to be moving into section 2. 5. I guess the previous rounds, 1 through 5 were from 2-4, if I misspoke earlier. Same mean, standard deviation, so 1.84. So Mr. Wilcox needs to have lap times that are less than 1.72 minutes. Find the proportion that are there. So 1.72, is here's just noticing that this 1.72 is not a number that's a standard deviation. So this tells us we should be using the table A values. So I want to find what percent that is. So we should be expecting something fairly small. So I want to find the z-score. So value minus mean over standard deviation. So let's calculate that up. Negative 1.7142 ... So rounding that to the 100th would be negative 1.71. And so we're going to go to table A. I have that right here. So 1.71. So 1.7, or this is not the 1, this is the 0, so that'd be 1.70. So 1.71 is here. So 0.0436. That is a small number, 4%, so matching what we said here. So it's about 4.36% of Mr. Wilcox's lap times were less than 1.72 minutes. All right. Let's see the next one here. Quick little picture. So 1.84, is that what it was? I forgot already. Sorry. Yep, 1.84. He would like his lap times consistently between 1.75 and 1.85. So 1.75 would be under 1.85. Be, very close to this. So we want all that space in there, so we're going to have to do both those z-scores. So z for 1.75, and then we'll do z for 1.85. I'd appreciate if you guys would, when you're doing problems with multiple things like this, we'd label those to help me follow along with you. Let's do the math here. So with rounding, I'm getting negative 1.29. With rounding here, I'm getting 0.14. I would expect the percentile here to be very close to 50% because that's just like a hair beyond that. So we know that mean should be 50%. But let's go to table A. So negative 1.29. 1.29 should be all the way over here. So, okay. Oh, 985. Write that down real quick. And 0.14 on the positive side. 0.14, 5557. So you can see it's pretty close to 50%, 5557. And then we either need to turn those into percents. In this subtract, I'm subtract and put them in percents. I'm just going to go ahead and subtract first. So I got 4572, so about 45.72% of Mr. Wilcox's laps were between 1.75 and 1.85 minutes. All right. And what proportion did he take more than 2 minutes? So it's more than 2 minutes, it's that keyword. So you're looking at a small number here, and we want to make sure that we get to the right side of this. We're going to just do that subtraction business. So 2 minus 1.84 over 0.07. Maybe 2.29 with rounding. And to table A we go. 2.29. So I'll get all the way to the end. So we're at 98.9890. 2.29. And so we're going to take 1 minus that, which is going to be 0.0110. About 1.1% of Mr. Wilcox's laps were longer than, or more than, or took longer than, I'll say that. Remember, it does not matter if it's like greater than or greater than or equal to, that the area of that line is so minuscule that it's not adding anything substantive to the area here. So we don't have to do like 2.01 or something like that. All right, last one of these. Says what lap time is necessary to be in as fast as 3%, or fast lap time is a low lap time. So it's reminding us that to be in a fast lap time, we want to be down here. And that's giving us the percentile here. So this is from 2.6. We're trying to find the value that would give us that percentile. And so, the percentile being 0.03 would be 3%. And so we're going to go to table A, but we're going to work backwards on this. So I want to find 0.03 in the meat of the table, and that's less than 50%. So I want to be on the negative side. I don't want to look here, or something like that. Like on those, I'm not giving a z-score. I'm getting a percentile. We're looking here for 0.03. So 0.01, 0.05, 0.03. Try to find the closest one to 0.03. All right, so these two right here are the closest to 0.03. This one's 1/10,000th off. This one's 6/10,000. So this one's gonna be the closest to 0.03. So what z-score gives us that? So running this back out, so I get negative 1.88. Negative 1.88 is my z-score from that. So that gives me a z-score of negative 1.88. Once we know that, we can set that equal to the value, which we don't know, minus the mean, which we do know, over the standard deviation, which we do know, and then solve for the